Thank you, and welcome all. Welcome to the discussion on circular nutrients for sustainable supply and energy independence. As said, my name is Kirsi Alman, and I work for the Central Balticum Foundation located here in Turku, and I will serve as the moderator for this discussion today. In this discussion, we will talk about nutrient recycling. By nutrient recycling, we mean the recovery and reuse of nutrients such as nitrogen, phosphorus, and potassium as part of the circular economy. These nutrients are used as fertilizers in agriculture. The challenges of nutrient recycling are therefore closely connected to issues like food production, nature, and sustainable development. With Russia's war of aggression, food security and self-sufficiency have entered the security debate as the war affected fertilizer prices. Russia plays a role in the fertilizer production, especially for nitrogen. Producing nitrogen is very energy intensive and mostly manufactured using Russian gas. Meanwhile, phosphorus used in fertilizers is imported from outside the EU. About 70% of the world's mined phosphate reserves are located in sub-Saharan Africa. Agriculture depends heavily on fertilizers, so any disruption in fertilizer markets can have significant consequences. Even before the war, some stakeholders were already concerned about the depletion of mined phosphorus, which is mainly used in fertilizers. This means that discussions on nutrient recycling have been ongoing for about 2 decades already, even before the war brought new attention to the issue. In Finland, nutrient recycling is often associated with the discussion on eutrophication of the Baltic Sea or on biogas production. Central Balticum Foundation is a partner in an Interreg Baltic Sea region-funded Synergy project, which focuses on recovering nutrients from agricultural, industrial, and municipal waste streams. The aim is to create fertilizers from recycled nutrients and promote nutrient recycling across the Baltic Sea region. Recycled nutrients support sustainable agriculture, environmental protection, and national self-sufficiency. Our panelists here today, Erik, Sari, and Tero, will tell us more about their work in our joint project during this session. And we will now proceed with our panelists, presenting first their prepared statements, focusing on their expertise in nutrient recycling. We'll start with Elsie. You're not a partner in our project, but you work in the EU level. So, you are the coordinator for Policy Area Nutri in the EU strategy for the Baltic Sea region. The strategy was launched in 2009, and Policy Area Nutri is one of the strategy's 14 thematic areas. The theme of nutrient recycling is a core part of your work, but what or who exactly are you coordinating?
Thank you, and thank you for having me here. That's a good question. Our effort is to try to coordinate people that are working in different topics that are related to reducing nutrient emissions or nutrient recycling. So we try to make people cooperate and produce more impact that are working in different projects, different stakeholders, and so on. The idea is to, by putting all the efforts together, to make more results and more impact eventually. Hope so, at least.
Yes, thank you, Elsie. And then next to me is Erik Sinjö. You work as a senior researcher at the RISE Research Institute of Sweden, and your work has a focus on bioeconomy and health thematics. You are leading the Synergy project that I just mentioned in the beginning. What kind of developments have you seen in the public debate on nutrient recycling?
Thank you, and thank you for inviting me here and for having this important, what I think is a very important session topic. As you mentioned, it's been the idea of nutrient recycling has been going on for maybe 20 years or so, a couple decades, if not longer. But I think I'm very happy that now, and I've been working for this in this for a long time, and for many years it was more or less nobody was really interested in nutrient recycling. But now, as you said, because of the background, because of the issues with the disruption of the global supply chain and the pandemic, and then the war in Ukraine disrupting the energy, the natural gas supply, the phosphorus issue. All of these issues are coming up, and it's becoming very understood, at least on a policy level, that we need circularity in our nutrients. We need circular bioeconomy around nutrients. We need this for a society, sustainable society in the long term. It's not just about agriculture, it's about securing our food supply, it's about energy, it's about waste management, it's about minimizing eutrophication. It's everything is tied into recycling nutrients, and I think it's becoming more and more known that we really do need to work on this, and that I think is very positive.
Thank you, Erik. And then on the other side, we have Sari Luostarinen. Sari works as a principal specialist at Luke, so Natural Resources Institute Finland, which functions under the Ministry of Agriculture and Forestry. Sari, you have worked with nutrient recycling for a long time and led, for example, the Man-U Standard project. What has changed in the nutrient recycling debate during your career?
Well, thanks again from my side as well for being able to join this session. I think I have to echo what you and Erik already said, that in the beginning, I think about 20 years ago, we were more thinking on the lines of that we would like to process, for instance, livestock manure to produce biogas, and the nutrients were sort of in the sidelines of that. But then gradually, the nutrient issue has become more important. It maybe started from the waste management point of view, that we need to reduce emissions into the environment, and we need to reduce the loading into the waters. But then all these issues about security of supply and self-sufficiency have become more and more important, and especially in the last few years after all these different disruptions in the sort of world order even. So for me, sort of like when we were working, we already knew these self-sufficiency issues and things like that before, but now they've sort of become really apparent for other people as well, other than working only in this line of issue. But so maybe that has evolved.
Mm-hmm. Yes. Okay, and then going to practical side, we have Tero Liukas, owner of the Tero Liukas Oy, which is a logistics company involved in the Synergy project. Your company has an agreement with HSY, which is Helsinki Region Environmental Services, to manage the marketing and distribution of liquid digestate from the Ämmässuo biogas plant directly to the farms. What kind of developments have you seen in the field during your time working with nutrient recycling?
This nutrient recycling is growing all the time, and it's more popular with the farmers. And this kaupan puoli, eli kaupan puolella niin ollaan myös.
You mean like businesses anyhow?
Niin kuin kaupan puolellakin on ymmärrä.
Koko lause.
Niin. Eli niin kaupatkin on alkanut jossain määrin ymmärtää kierrätystä.
Yeah, even like grocery stores and different businesses are becoming more involved in recycling.
Yeah. Okay, so that was a short opening round, and great to have you all here, if I didn't say that already. So we will now move on to hear more and go into more depth to the thematics. We will now do it so that we'll start with Tero this time. Okay. So this intervention will then highlight really concrete actions in nutrient recycling, and then the following statements will build on this, moving step by step to the EU level. So Tero, your company has invested in NIR technology. Yeah. You can tell about this, which allows for precise measurement of nutrients in transported slurry. From your perspective, from a perspective of entrepreneur, how has nutrient recycling appeared in your work? What kind of investments has it required? We would be interested to hear more about this.
Okay.
Yes, and you have slides, and I have the click here. Oops. Let's see. Does it work like this? Yes, we have a picture behind me.
I think it's okay.
Okay, my company works with nutrient recycling. We move slurry from farms to field and to biogas plants. And we bring digestate from biogas plants back to the fields. And why I do this work? Because I see clearly how farm byproducts can be turned into energy and the fertilizers. Biogas plants use slurry for energy production. This process turns slurry into digestate. And digestate can be used in the fertilizers. When digestate is used well, it reduces chemical fertilizers, it cuts emissions, it saves farmers money, and biogas can replace fossil fuels. So, logistics is not only transport, it's part of the circular economy. And when I started about 18 years ago, Finland had only few small biogas plants. Recycling was not systematic. Today things are very different. Biogas plants are growing fast, storage, spreading of nutrients are planned, and data guides more and more of the work. For my company, this means we invest not only trucks but also in the new technology. One of the biggest steps has been NIR technology. We use EVONIR device made by Dinamica Generale. And this Dinamica Generale is the world's leading maker of NIR devices. They have more than 15 years of experience. And today, I also have one NIR device here with me. And this tool we use in practice directly on our trucks or trailers. With this device, nutrients measured instantly, right at the farms or biogas plant. So what you see here, it's not theory. It's real practical technology already working in Finland. And how does it work? The light shining the slurry and the spectrum is red. Each nutrient has some kind of own fingerprint and each nutrient, nitrogen, phosphorus, potassium, and dry matter has own fingerprint. So the software shows result instantly. So the nutrient levels are known before transport begins. And why this is so important? It means we know nutrient content right away, not for a days or week later from the lab. Farms can plan fertilization more accurately and to add more or take away some nutrients when fertilizing. Biogas plant gets real-time information on feedstock quality. For example, a pig farm, the nutrient content of manure depends on the feed. If the feed changes, the nutrient levels and the dry matter can also change. This EVONIR shows that immediately. This helps farms make better fertilization plans. And this kind of NIR is used already in the feeding to study feed inputs in the farm animals. In the future, EVONIR could also show the true gas potential of manure and grass feedstock. This is very good news for the biogas plant. And about this, our Sinulki project, we have very good results in this project, and that's the reason why we bought 2 more devices in our trucks. And now we have 3 Evonir in our trucks, and worldwide only 4 are installed on the trucks. So my company is truly global front runner. And the potential of the NIR is very big. Already today, there are versions that can study grass silage and other biomass. Soon it may be possible to only to measure nutrients, but also analysis of true gas potential of manure and grass feedstock. This means more opportunities. For farms, better data nutrients, better fertilization plants, improved production of food and energy. For biogas plants, the change to know feedstock quality and gas potential before processing. For farms in the future, energy production could become an extra source of income. In short, nutrient recycling is my everyday work, not on the road. On the road and in the field. It's not an idea, it's the real solution that connects farms, plants, and logistics. My motivation comes from this. We can join economy and environment and make nutrient recycling both good business and path to sustainable future. Thanks.
Thank you, Tero.
Yeah.
I think you had a couple of more pictures.
Yeah.
This is the second one. Then we had here.
And there is the NIR device in the truck. Mm-hmm. And there is the screen where we see every crop and the levels of the crop.
Yeah, maybe one more.
That's an example of how the results are shown in the system.
Yeah. I think it's amazing that when you say that 4 of these machines in the world and you have 3.
Yeah.
That's, that is top notch. Definitely. Thank you, Tero. Yes. Okay, then moving to Sari. So Luke is a partner organization in Sinulki project, and Luke has this experimental facility Biopaja, which is located in Jokioinen, and this Biopaja plays an important role in cooperation with Tero's company. And I have understood that Biopaja contributes to the project's support center function, providing technical support for nutrient recycling trials. And those samples analyzed with NIR technology are sent to Biopaja. So based on your work in this project and of course your earlier experience in general, can you tell us where nutrient-rich resources are located and where the recycling actions should be targeted at the moment?
Okay, so first about our cooperation between Luke and Tero's company. So the NRI system it's a near-infrared system that, as Tero said, is sort of reading the samples and then comparing it to a big data base of similar materials and trying to identify the level of nutrient content in the slurry or digestate or whatever being transported. So you need to have this database and to sort of calibrate the system as best possible for the Finnish slurries and digestates and such transported. We've been taking samples so that they are analyzed with the NRI device and then in our lab, so that we can make sure that the results the system gives when transporting these materials to the farms or to the biogas plants is as accurate as possible. And then to this question of where these nutrient recycling activities should be sort of targeted. It depends well, basically two things. The other one is that where these recyclable biomasses are located and where the nutrients are needed. So you need to be able to compare that. So in the Synergy project and also nationally in Finland, we have been working on trying to estimate the nutrient recycling potential in the Baltic Sea region. And this is something that we do by calculating how much of these different recyclable biomasses we have in the countries and where they are located and how much of nitrogen and phosphorus they contain. So these biomasses that I refer to, they mostly include livestock manure, which is usually in every country the major recyclable biomass. It contains the most of nitrogen and phosphorus to be recycled. But then it can also be sewage sludge from the wastewater treatment plants, municipal bio-waste that each of us hopefully carefully sort at our homes and in the restaurants, canteens, other public places to eat. And then it can be some industrial materials, for instance, from food processing industry. There's several side streams that can be recycled as fertilizing products after processing. But then, so we try to figure out how much of these materials is being produced in each country and how much nitrogen and phosphorus they contain. And then we try to figure out as precisely as possible where they are located, so that where we have these materials, and then we compare that to where the fields needing the phosphorus and nitrogen are located. And when we see sort of a conflict there, that in this area there's too few recyclable biomasses with the nutrients in comparison to how much fertilization is needed there, then we talk about a deficit area. And then in some other places there is a surplus. So there's a lot of recyclable biomasses available, but not all is needed around the same place for fertilization. So this way we can see that where we need to do nutrient recycling activities so that we are able to transport from the surplus areas to the deficit areas, and also to regionally just sort of relocate the nutrients to the places where they are needed. So that's what we are doing. And I actually have a Finnish map here as an example. This is these kind of things we are doing in Finland. So this is in the municipal level. And there's a comparison between phosphorus in livestock manure and then phosphorus fertilization need in each municipality. And then you can easily see where there's most surplus with the darker colors and where there's deficit of livestock manure phosphorus in comparison to the fertilization need. So we are able to see that in the western and southwestern part of Finland, we should do some things to relocate part of the manure phosphorus to other parts of the country. So I think, yeah.
Good. Thank you.
We're doing these same kind of things to the other countries in the Baltic Sea region now.
Mm-hmm. Yes. And when talking about our joint project, as said in the beginning, the aim is to expand the nutrient recycling beyond agriculture into municipal and industrial waste streams. So, Erik, as I have said many times already, we have so many years of experience in this panel, and as do you personally as well. What challenges have you encountered in moving from beyond manure to other nutrient-rich resources?
That's a really good question. As Saudi pointed out, manure is, in general, it's the largest source of a nutrient-rich biomass of different types of waste streams in all countries around the Baltic Sea. Manure is generally, it's in most cases, most farms, livestock farms have cropping fields close by. So we have a long history of utilizing the nutrients in manure in agriculture, recycling them back to agriculture. So for many years, what Saudi and I have been focusing on is just trying to make that use of manure more efficient, trying to decrease losses of nutrients and trying to make sure that more of it is used in the crop production. But now, as we're moving toward circular nutrient systems and a bioeconomy around nutrients, we're looking at other waste streams, and we're also seeing, and what we've seen in many cases, that there are areas, many of these darker areas are where the livestock density is actually too high for the agriculture around. So you have kind of a surplus of nutrients, even though there's agriculture around. So then we come into these issues, then we come into these aspects. How are we going to move? It's kind of a technical issue. Now we lost the picture up there, but you remember what it looked like. There's a big distance between areas where they have the surplus and where we have the deficit. So one of the big problems is with manure and with digestate from the biogas plants. So this excellent way for us to recycle many of the other waste streams from household waste, from restaurants, from food industry, goes to the biogas plant, we extract the energy, and then we have the digestate afterwards where the nutrients are, and that we need to get back to agriculture. The only problem is it's about 95% water. So there's a lot of transport with water, and that's just not efficient when we're looking at these distant scales that we need to be able to do. So where a lot of our research and development is going in now is technical solutions for separating the nutrients out of these waste streams and concentrating them into fertilizer products that can be transported at a greater distance without increasing carbon dioxide emissions and using diesel consumption and everything else that goes along that. So these technological issues of separating the nutrients, concentrating them, and producing products is really what's going to be key to being able to redistribute nutrients to have a more balanced regional nutrient level and without having the surplus and the deficit. And also when we do that, because these areas of deficit, what they're using now is they're importing mineral fertilizers to be able to use that. So the idea with nutrient recycling is that if we can create nutrient products from these surplus nutrients, then we can reduce our dependence on mineral fertilizers. We can reduce our dependence on mined phosphorus and natural gas produced nitrogen fertilizers. So this is a win-win solution. Plus it's also dealing with the decreasing waste stream. Having a more effective balance is going to decrease losses, so it'll reduce eutrophication, which is a big win for the Baltic Sea and for our water ecosystems. So these technological issues are a big challenge. I don't want to take up too much time because we need questions in the end, but there are a lot more that needs to go in that, because to be able to jumpstart this, we need policy support. We need help to encourage, to make it easier, because there are a lot of technologies that are working, but they're very small scale, and we need a lot of structural support in the system to be able to create industry standards for how these different small scale products are going to look and work, so that farmers know how to use the products. Farmers can feel confident in using these alternative fertilizers, and so that everything will be worked in. So we also, in the project Synergy and another sister project, Fertitech, which is a Horizon Europe project, we're working very much on these other aspects as well, not just technology solutions for the actual technology of recycling the nutrients into products, but also drafting industry standards for how to how to evaluate these different products in reference to mineral fertilizers, which farmers are used to using. We're also looking at how to develop policy support and increase acceptance of these alternative fertilizers among farmers. So all of these different aspects really need to be taken into trying to find solutions that are going to work and that are going to lead us in the long term to be able to reduce our dependence on mineral fertilizers. I think I said enough now.
Yeah. Thank you, Erik. Yeah, I think this bridges the discussion nicely to the next level, meaning the EU level that I promised in the beginning. You mentioned policy support needed, structural support needed, balanced regional nutrient level, and this brings us to macro-regional level and then EU level. So, Elsie, as the coordinator of Policy Area Nutri, working with the implementation of the EU strategy for the Baltic Sea region, can you tell us about the goals for nutrient recycling within your specific policy area? And how does the strategy affect nutrient recycling?
Thank you. Maybe a few words about the whole strategy first. We have quite many different policy areas that are working inside the EU SPSR. It covers basically the whole society, and saving the sea is under it as one of the main objectives. There we have Policy Area Nutri, also hazards, bioeconomy, and so on. And as a whole, the whole strategy, our aim is to help with the cooperation, of course, but also cooperate with so-called third countries, because we are EU strategy, then it's important for us to also reach out to countries that are in the process of joining EU or candidate countries. So Ukraine, for example, is important stakeholder for us nowadays. And as a whole, basically, the idea is to help people cooperate so we can make more impact, like I mentioned at the beginning. Yes, seuraava vielä. And for policy area, nutrient recycling is just one of the main actions that we have, but is very important. For the Baltic Sea, we have Helsinki Commission that is leading kind of the policy making in the region, and they have something called Baltic Sea Action Plan, and it has actions in it that are focused on nutrient recycling. So those are very important. And it also has regional nutrient recycling strategy. There's specifically promoting nutrient recycling. And Nutri is coordinated by Center for Economic Development, Transport and the Environment for the Southwest Finland, so-called ELY Center here in Turku. And we have a second coordinator in Poland, kind of a state-level authority for water issues. And I wanted to kind of show all the different kinds of policies that are in EU level that are relevant for the nutrient recycling. It's a very complex topic, and it is systemic. To make the nutrient recycling work needs systemic change. So that's why it involves lots of different policies. And lots of the policies that are relevant are also being updated, or new ones are coming up. But it's important to notice that both the HELCOM Baltic Sea Action Plan and the EU policies, none of them have binding targets for nutrient recycling still. They are voluntary. And of course, there is discussion now that should we have binding targets. For example, the EU Urban Wastewater Treatment Directive only has mentioned to encourage reuse of nutrients. And it kind of prepares the field for developing further policies that would be supporting it. For example, EU Green Deal mentions legal requirements to boost the market for secondary raw materials with mandatory recycled content as a goal, but it hasn't happened yet. And also EU Circular Economy Action Plan refers to stimulating the market for recovered nutrients. So far there is no EU proposals published that would be doing that. Also, on top of the wastewater sector, agriculture is, like mentioned, even the bigger and more important for nutrient recycling. And in CAP policy, in Common Agricultural Policy, there is possible to make eco schemes kind of for supporting nutrient recycling, but how it's implemented in different countries differs really a lot. Finland has good policies already existing, but it seems that we are front runners in that sense that not many countries are that far yet. And this is one thing that we are also helping the countries to cooperate, that telling them that what kind of policies are developed in other countries so they can learn and also develop similar or improved policies in their own countries. We have done that through, for example, so-called PNutri talks, webinars, where we are presenting the policies from different countries, but also ideas for policies or challenges that different projects are working on. So bioeconomy is, of course, at the core kind of for nutrient recycling, and EU is now updating the bioeconomy strategy. The original one was published already some time ago, and now we are expecting that maybe we will have a new strategy end of this year, maybe next year. And we held this one of the ideas how we are helping the stakeholders cooperate is we participated to the EU's open consultation on the new bioeconomy strategy by making a joint statement with different projects. And Synergy, of course, was their major contributor, giving us a long list of different policy recommendations and so on. Many different projects participated, and we were able to make a joint statement that kind of emphasizes the issues that are relevant for the Baltic Sea region especially. This helps to make the EU policies relevant for the regions and for the kind of the local issues, like taking into account the bad state of the Baltic Sea, for example, better, hopefully, in the how the policies are written in the future. So, yeah, hopefully these kind of efforts will be continuing with new policies that will be in development. And I hope to see that in the EU level there will be a lot more coming than the bioeconomy strategy. I think now is really good time to help kind of develop the future that we want to see.
Yes, thank you. Thank you, Elsie. And in case you're interested in the EU strategy for the Baltic Sea region, contact Elsie or contact any of my colleagues, as it is so that Finland is very active in the strategy, in implementation of it, and Centrum Balticum Foundation is in the very core of the strategy. Here in Turku, Centrum Balticum hosts the Baltic Sea Strategy Point, which is the secretariat for the strategy, and we do the work together with our colleagues from the city of Hamburg. So many things happening here in Turku and in Finland in general, in relation to the EU level practical work. I think it's now time to move on to the questions from audience. I have the iPad here. I don't think I have questions here yet to our session. I don't see any. I think we do have the possibility for a mic here also. So are there any questions from the audience here in the room? Yes, there's one up there.
Can you go back to the slides?
So can we get the slides here as well? I can see it here in the...
If we go back four slides.
4, okay, that was 1, 2, 3, and 4, I think, or not. Is this one?
Now it's coming. Yeah.
This one?
Yeah.
Okay.
Can you hear me okay? So I'm just a layperson, and much of what you said, you must admit, is sort of very technical, goes right over people's heads. But I'm interested in Action Plan 1 and 2 there. You've got reduced nutrient emissions from agriculture and other diffuse sources, reduce nutrient emissions from urban areas. Can you give some practical examples of how that's happening for ordinary people, how the EU may be trying to encourage that? You're talking a lot about hopeful policies for the future. I think for the ordinary person who comes on here, like me, we'd need to know, how can we do something? How is the EU trying to encourage point 1 and 2? Is that okay? And I think also the Swedish guy said about how we can get people to sort of accept this, or some practical examples.
Do you mean in relation to nutrient recycling especially, or in general with agriculture and urban areas?
Yeah, agriculture, but you've also got things like urban areas. I'm going to presume that's ordinary people.
Most of the urban areas refers to wastewater treatment. So, of course, you use toilet like everybody does. So the waste goes to the wastewater treatment plants, and now the EU has just updated the urban wastewater treatment directive. So that is already increasing the how much of the nutrients have to be removed from the emissions that go to the sea, for example. So there is a kind of period that will now take place. I don't remember, was it even more than 10 years or something, that we will be increasing the limits, how much can go to the sea. But the biggest change maybe is that smaller municipalities than before have to have a centralized wastewater treatment. And then there are also lots of projects going on. For example, Nurse Coast project that is working on towns like maybe here in Finland, some of the small islands on the archipelago, they will have a problem of many tourists going there during the summer and kind of putting pressure on the wastewater treatment, so it kind of gets overburdened very easily. So new technical solutions are being developed for that.
Maybe I can also give a really practical example referring to the toilet. Don't flush any pharmaceuticals. Don't put your extra medicine into the loo, but take it to the pharmacist. They will recycle it properly and be dealing with it. And from the agricultural side, what can a layperson do? You can fix your diet maybe, follow the recommendations on how much meat you should be consuming, eat a lot of green things. These have an effect on the agricultural production, on the nutrient use, and eventually on the environment.
Yeah. What about you, Erik? Shortly.
Yeah, shortly. From the agricultural side, what can we do to try to help us achieve these reducing nutrient emissions? There, I think it's along the lines. I mean, from the farmer's perspective, there's a lot of things a farmer can do, but as the consumer, what can we do? And I think that's to buy locally, support local farmers, and support farmers who are implementing good practices. I think good practices are really they're the key, but using best available techniques and technologies in farming and agriculture is the key in supporting farmers that are doing this, even if it costs a little bit more to support these farmers. This is a big issue.
Thank you. I think we have used our time in this Euroforum this year. Thank you, speakers. Thank you to our audience, and I wish you, on behalf of Central Balticum Foundation, fruitful days in Euroforum tomorrow and then Friday too. Thank you. Thank you.